it's a better way to think
Until we
about
get more things moving, then we got a problem. So 7. I have a rocket sitting on a launch pad ready to go. Afterwards, I'm going to send it as part of it'll be part of the notes that you guys. Okay, afterwards I have gas coming out the back. I have 0.050 kilograms. And it's traveling at 600 meters per second. In this direction, I have a rocket going up. And we don't know what its velocity is, but its mass is 4.0 kilograms. Disregard gravitational effects. So, because we don't want to figure out what the Earth is doing in response to the rocket being launched. We don't want to know. So what do we do? Momentum before is momentum after. So momentum before is, so no, you're right. Let's write that down. Thank you. Momentum before is, what's moving? Nothing. 0. Afterwards, I have 4.5 times V. It's 4.5, right? 4.0. Carry my own writing. 4.0 times V. Plus, I have 0.050 times
minus
negative 600. Well, it's the direction that makes a difference, right? It's velocity that has the direction on it. Okay. So it's good. So then I do a little work. I get 4V plus 20. So that'd be what, 30? Is that right? 30?
Negative 30, yeah.
Right, negative 30. Bring that over. I get negative 30 equals 4V. V equals, no, it should be negative, it should be positive now that I've moved it. That's dumb. 7.5 meters per second. Okay? That's the way I would choose to do it. Does that make sense? The wrong way. The wrong way according to Peter, but again, you haven't seen the problems that are coming, and so therefore.
This seems way better.
Okay. All right. Whoops, I didn't hit pause well enough. It's going to have all this. Number 9.
Can you answer in centimeters per second?
Well, you could actually do it in this case. I would convert everything just because that's going to be your habit, right? All right. Compressed Briggs exponent of the red burn, the 1.5. So I have 0. Momentum before equals momentum after. Nothing's moving at the beginning, so momentum before is 0. Momentum after is 1.5 times, I would write negative 27 myself, or negative 0.27 myself, to stay consistent and turn everything meters per second, plus 4.5, and I don't know what its velocity is. So I guess I'm solving for that, right? Fair enough? So then I'm going to go ahead and throw this together. Battery's low, please replace. Just get off my screen. Battery's low, please replace. 1.5 times negative 2.7 gives me negative 4.05. 4.5V. Move that over, I get 4.05 equals 40.5V. And I get negative 0.9, not 0.09. Other than that, it's pretty good. Meters per second. What did you wrong? Yeah.
Yeah.
Oh, I did that wrong too. Yeah, I did 2.7. So you are right. I'm wrong. Put that over here. Whoop. And if that's over there, then that'd be over here, which makes it 0.09. Makes her absolutely correct. By the way, negative left. Wait, I made that negative to begin with, so that should have been positive. So I should have that, so it should be right. Right? Which makes sense. It should go to the right. Good?
Can you do 10?
I guess I can do 10. Is everybody good so far? Let's do 10 then. Wait, that was number, I don't know what I did there. A 0.005 kilogram projectile is launched with a horizontal velocity of 647 meters per second. So I got a projectile launched with that speed. From some sort of launcher that is 4.65 kilograms. What is the velocity of the launcher after the projectile is fired? So before the projectile is fired, with momentum before? 0. So momentum before equals momentum after. Momentum before is 0. Momentum after is 4.65 times whatever its velocity is, plus 0.005. The way I drew it, this would be positive. Could you draw it so it'd be negative? Yes. But I didn't draw it that way, so I'm going to stick with what I drew.
Okay, you don't have to keep going. Just want to make sure.
So I should get a negative answer of some sort. Are we good with that one? All right. Should be good there. Yes, ma'am. So now we're switching to 6.5, number 8. 6.5, number 8, a 20, nope, yes. Sam, mass of 50 kilograms, little guy. Skating on a flat level surface, pushing a shopping cart. Well, what an unusual thing for a kid to do, but you know, he's having fun. Okay, he's pushing a shopping cart, which is 20 kilograms itself. And he is traveling with a speed of 5 meters per second when he does what? Sam spots mall security and pushes the cart so that it has a speed of 10 meters per second. What's the speed and direction of Sam immediately following the push? So, momentum before equals momentum after. And this is where we start to part company with Peter. Okay. Why do we part company with Peter? Because I have momentum before, so now I'm going to be much more careful about how I do things. Okay? So look at this and I go, all right, momentum before is, what's my mass?
70.
70. I'm traveling at 5. And then I've got momentum after, so I've got 50. I don't know what its velocity is. Plus I have 20 times, what's the velocity of the cart?
10.
10.
And just solve.
And solve.
Solve for me.
So I got 350 equals 50V plus 200. 150 equals 50V. V equals 3 meters per second. So what happens is he doesn't change directions. He what? Slows down. And hopefully doesn't get caught with the cart.
Mr. Esney, if it's any constellation, I set it up that way.
Excellent. That's why I was feeding that into you, because I knew you would eventually go, okay, when I get to have to do it, I'll do it that way. Good? Connor next, am I doing good? All right, let's do number 6, which is the last one we wanted to do. 6.5, number 6.
I don't need number 6. I thought.
You don't need number 6?
Do
Number
the
6
heck
is
of
like
it.
one of my favorite problems. All right, I want to do 6. You don't get to do 6. Any other questions? Anybody's got it, everyone?
Do it.
You want to do 6? So I do 6. Okay, I got a magnet. It's slid across an icy surface, picking up iron filings as it goes. Initially, the mass is 0.400 kilograms, and has a speed of 10 meters per second. What's its speed after it picks up 0.15 kilograms of iron filings? What's its new speed? Wait, why would it have a new speed? For mass. Now, from a force point of view, we can make the argument as each one of those particles hit, it's got accelerated up to that speed, right? So it's applying a force to the magnet, applying a force to the individual particles. We could actually try to calculate that. So rather than do that, what are we going to do? Momentum before equals momentum after. Momentum before is 0.400 times 10. Momentum after is going to be 0.55, isn't it?
Yeah.
Did I write down the numbers wrong?
You add just the point.
Just add them, right?
Yeah.
So it's 0.4 plus 0.15. 0.55 times its new velocity. So this is just 4 equals 0.55 V. V would therefore be equal to what?
7.3.
7.3 meters per second in the original direction. Got it? Happy, sad? We can do this?
Physics. My question is,
Well, it's a great